All right, welcome to our presentation. I'm Brett, and we have Jason and JR as well. This presentation is a basic summary of what we have covered over the past several weeks in class. We'll begin going over the following: 7 steps to the development process, selection statements, scope and encapsulation, variable lifespan, and passing arguments. Let's start with our development process. 7 steps to the development process is a system designed to take problems or tasks and create solutions that we can ultimately push to our end users. In step 1, we want to clearly define the problem. What is it we need to accomplish? Using a team assignment as an example, we'll tackle the problem of having a player cross a river in the Oregon Trail. To clearly define this problem, we'll state the player needs to know their chances for successfully crossing the river while taking into account the river depth and their current weight. Now that we have the problem defined, let's break it up into manageable tasks. We have our goal, which is calculate the probability of crossing a river on the Oregon Trail. We have the inputs we know we'll need and the conditions that we need to make sure we follow in order to make sure the program will run without any errors. Now that we have a problem clearly defined, we can create a test matrix to run some specific values to ensure that we have valid inputs and boundaries defined. To outline the solution, we'll use a formula to calculate the probability of success. Using pseudocode, we can create a formula to account for our inputs and receive an acceptable output. Note that we've also accounted for any potential invalid errors and to handle them appropriately. Now we need to test the algorithm we created. Using this test case chart, we can take our test matrix values and one by one enter each value into our formula to ensure that we receive the output expected. Step 5 puts our theories to the test. We take our algorithm and translate it into usable code. Now that we have our code, it's time to run the test cases through an actual compiler. This is made easy using JUnit. Here we are inside of our river scene control class. You can see our function here. If I right-click the class and move down to Tools, Create Update Tests, JUnit will create a special test class for us. This has already been done, so we're going to go to our test packages, Oregon Trail Control, River Scene Control Test. All right, here's our test function that was created by JUnit. You can see that we have 7 test cases. These are just like the ones that we created in our test case table. The first line here is merely an output statement for us to be able to see what test number we're on. Below that, we have our input variables, river depth, current weight, and max weight. You can see that the values from the table are statically entered here. After that, we have a new instance of our river scene control class being created. Expected result is our output, as you can see right here. The next line calls our function using the variables above and stores the returned value inside of a variable named result. The assert equals function will compare our expected result with the actual result. If they're equal, the test will pass. If not, it means something in our formula went wrong and we'll need to troubleshoot. Each test case inside of our function reflects the values from our test case table. To run the test, we're going to right-click our class and click Test File. Our test results pop up here. As you can see, we had a 100% success rate. You can see that all 7 test cases were run, so we know that each test was run successfully. Once all the test cases have passed, we can deploy our changes to the repository, always making sure to pull before pushing. Up next is selection statements and passing arguments.
And I'll go over selection statements and passing arguments. First, we'll go over selection statements. There are basically 4 types of selection statements that we show down below. Selecting the appropriate type will depend on the number of choices that will need to be made. Also, using these type of statements, they're usually executed regardless of the type being used. The if statement, you basically want to use that when there's only one true action. The false action is ignored, and the block and the script go to the next statement. The if-else statement is when there is only one condition, and there is a true action and a false action. It basically does either or of those conditions. If you have more than one condition, then you want to use the if-else-if ladder statement to basically go over the different conditions. And lastly, you could use the switch statement, which uses more than 2 actions, and it's based on a different condition. So going over the first if statement example, you're familiar with what we did in the last lesson with it, the menu. In there, you have one example here that shows the if statement and only has one true condition. And it basically takes the value and sees the length. And if the length is less than 1, then it prints out that value. If the value continues on, it goes to the display menu, and this menu option is stored in a string. And basically it goes through another if statement that checks to see whether it was the user's input was either a Q or something else. If it was Q, then it checks on that one if statement condition and returns the result. If not, it passes the menu option string variable to the do action function, which we'll go over next. When we pass the menu option, we're passing the variable, the primitive variable string. And we're passing it to this switch statement so that we can perform a specific action. That's probably when the best time to use the switch statement is when you want to perform different functions based on the user's input. In this case statement, we take one of the menu options. It takes the menu option that's stored in the string and compares it to each of the cases. When it matches a case, it performs the necessary function. If it doesn't have one of the case, it defaults out and says it's not in the selection in the case statement. And then we go on to the next one. So in this one, we're doing the if-else if, and we're testing various conditions. Basically, I'm showing an example of my hunt control function that basically calculates the amount of food that a user will get on a successful hunt. So it goes through an if-else ladder conditions where it first checks to see the character's hunting skill, and then it checks on the conditions of the wildlife amount, and then it checks the conditions of the character's stamina. And if either one of these conditions is true, then it will return -1. Else, if it's false, it will perform the calculation and store the return amount food inside the variable amount food, which will go into our next. Lastly, you can pass arguments by reference. So say I want to take that last example with the amount food, and let's say we called that same control function, which is calc hunt success, and we stored it in that variable in amount food. Now let's say we want to update the player's amount food now based on their hunt that they just did. So we would make a new player instance called player 1, and then we would pass this player 1 instance into a function called update player food. So we're passing by reference the player 1, and we're passing the primitive value amount food to the update player food function down below. And down below, we update the players. We first get the player 1's reference of the food that they have, and then we total the amount of food that we got from the hunt. And then we are able to set the player 1's food based on that total. So that gives you an idea of how we can pass argument by reference.
Now let's talk about scope, encapsulation, and variable lifespan.
All right, so what is the scope of a variable in Java? The scope of a variable specifies the region of the source program where that variable is known, accessible, and can be used. Understanding this concept lets you know when you can use this variable. Have you ever seen the same variable name in 2 different places but had different values? Or has your Java compiler ever given you an error because there's no reference to that variable you wrote in your code? This is why variable scope is important. There are 3 types of variables: instant variables, argument variables, and local variables. Instant that are defined within the class itself and not in any method or constructor of the class. The scope of instant variables is determined by the access specifier that is applied to these variables. An access modifier restricts the access of a class, constructor, data member, and method in another class. While looking or practicing Java programs, you have seen these keywords such as default, private, protected, or public. Before I forget, another key concept to know is the lifespan of a variable. So what is the lifespan or lifetime of a variable in Java? The lifespan of a variable refers to how long the variable exists before it is destroyed. In other words, the lifespan of a variable refers to how long a variable stays alive in memory. The lifespan starts when the variable is first defined and allocated in memory. So let's go back to talking about instance variables. The lifespan of these variables is the same as the lifespan of the object to which it belongs. And now argument variables are defined in the header of the constructor or method. The scope of these variables is the method or constructor in which they are defined. The lifetime is limited to the time for which the method keeps executing. Once the method finishes execution, these variables are destroyed. All other variables which are not instance and class variables are treated as local variables. The scope of a local variable is within the block in which it is declared, and the lifespan of the local variable is until the control leaves the block in which it is declared. Now let's take a look at the character class our group created for the Oregon Trail game. In Java, there are some variables that you want to be able to access from anywhere within a Java class. As you can see, the variable name has been created at the top of the class. This is a class level scope because you're able to use this variable throughout the entire class. In the getter and setter constructors, you can see that the functions getName and setName both call for the variable name. Some variables you might want to make temporary, and preferably they are used for only one method. Let's look at that public void setName down there in the yellow block. This keyword helps Java to differentiate between the local scope variable, the method scope variable, and the class variable. This .name tells Java that you are referencing the class variable. So the setter sets the method scope variable called name to the class variable called name. The variable scope here is not in conflict because Java knows which variable to access because of the this keyword. Now let's take a look at the map control class to show the lifespan of a variable in method. I won't go through all the math here, but at the end of the else function that is highlighted in red here, you can see that miles is equal to miles multiplied by health check plus weight check divided by 2, and then it's rounded to a whole number right there in the green box. Once that function ends, the variable is sent somewhere, and the variable sent somewhere. The variable is then destroyed, in other words, taken out of memory. So when the function gets called again, everything is reset, and miles this time around might be a different value. So the variable's lifespan only lasts for how long that function is calculating the equation. So once it gets the answer, it gives the answer, and then as soon as somebody calls for this function again, it wipes the memory clean, and there's nothing in that miles where the green box is highlighted. And finally, let's take a look at encapsulation. So what is encapsulation? Encapsulation simply means binding object fields and methods together. Basically, when you create a class, you are doing encapsulation. The whole idea behind encapsulation is to hide the implementation details from users. Remember earlier I talked about access modifiers, default, private, protected, or public. As you can see in the river scene and the river scene class below, the scene and river depth variables are labeled as private. What that means is that those variables can only be accessed within the same class. No outside class can access private variables of another class. However, if we set up getter and setter methods to update and read the private data fields, then the outside class can access those private data fields via public methods.
This concludes our presentation. Thank you.